I pulled this group of people together today because I want to talk about some of the issues in the FCC's Restoring Internet Freedom docket, which is essentially the proceeding that asks the question of whether the net neutrality regulation should be reformulated under Title I away from their current Title II status. And one of the arguments that has been made for that on a technical basis came from the Electronic Frontier Foundation, who assembled a letter, had it signed by a pretty large group of internet technologists, which argued, as I read it, that the internet service providers should be regulated under Title II because the service that they provide is very similar to the telephone network. And in fact, they even went so far as to say that the networks that these providers operate work pretty much the same way that the telephone network does. So, so that's what we're going to explore. So let me give you some bios for folks who aren't familiar with panelists. Tom Evslin was the founder of ITXC, which is a really innovative company in the, was it late 90s, early 2000s?
Late 90s, right?
Yeah, transported telephone calls over the internet. First company that ever did that. In 2002, they were rated as the fastest growing tech company in the country by Deloitte & Touche. And Tom's also been a chief technology officer for the state of Vermont. And he currently runs a very interesting business that transports natural gas over trucks in areas that don't have pipelines, which I find kind of oddly similar to the kind of thing that ITXC was doing, transporting telephone calls over the internet.
Correct.
And Tom was also responsible for the conception, launch, and operation of AT&T's first ISP, WorldNet, the WorldNet service. And you can read more about Tom on Wikipedia. He's got a page. Barry, who just joined us, is the founder and operator of the world's first commercial ISP. And he's been named one of the 11 people who made the internet happen because of his ISP, which is called The World. Hence, Barry's Twitter handle is World Leader. Maybe a little tongue-in-cheek, yeah. And there's a page that BT put up of the 11 people that made the internet happen, in which Barry is included. It shows an ad for the World Service from 2010 with gold accounts that had, for $20 a month, you got email space, web space, your own website, 2 mailing lists, and Unix shell access. So that was quite a bundle of services. And that's still on offer today, right, Barry?
It is.
Yeah.
We're still going. We even still have dial-up if you want it. I don't know for how longer, but.
Yeah. And incidentally, the other two panelists have both been Barry's customers. So you know your impact is really pretty amazing. Barry was also on the board of directors of Usenix, which played an odd role in the creation of UUNet, which was one of the first internet commercial backbones that sort of helped in the transition of the internet from a research network to a network for the general public and for commerce. And John Day is a lecturer in computer science at the Boston University Metropolitan College, computer scientist, an internet pioneer, and a historian, and quite a historian at that. You've probably heard people talk about the 7-layer model for network architecture. Well, John's the guy who put that together.
That's a bit of an exaggeration.
John chose the guy who put it together. It was the rapporteur, right, for the OSI.
Yeah, it was Charlie Bachman's idea.
Yeah. So we're going to talk about protocol layers after a while, and I guess John's about as much of an authority on that as anyone can be. He wrote the book in 2008, a book called Patterns in Network Architecture, A Return to Fundamentals, which I believe is the best, by far, the best overview of network architecture as well as the politics of the development of the ISO protocols in the 1980s that at the time were believed to be what the internet was going to be based on. So the internet, the TCP/IP internet that we use today, there was sort of a consensus position in the computer industry that that was a transitional stage that we were going to pass through, and OSI was going to be the real thing, but politics got in the way of that and a bit of over-design. John's also published articles on the history of cartography. And if you want to talk to somebody about the map not being the territory, you know, he's your man. And the author of 4 early RFCs in the 3-digit number range, 520, 728, 731, and 732. He publishes articles on cartography still, and he's been cited by which auction house? Christie's, yeah, on the authenticity of some of these maps that people like to buy. And John has a Wikipedia page too. So folks, thanks for agreeing to do this. And I'm really kind of jazzed, and this thing actually seems to be sort of working, which is amazing to me. But tell me, now that, you know, you've all read the EFF letter, should we sign?
Well, the EFF is just wrong. About facts, and then I disagree with them on opinion. It's hard to say somebody's wrong on an opinion. The internet and the phone network work, as everybody on the panel knows, in very different ways, almost diametrically opposed ways. I'm very aware of that because the company I built that you mentioned, ITXC, which was a wholesaler of voice over IP, we were in the middle of phone calls, used the internet to replace the PSTN, the public switch telephone network. And our success depended on the fact that the technology was completely different. The routing was completely different. Just to give a tiny example, a phone call travels over something called a call path, which means every bit of information goes on the exact same path as every other bit, or else the call breaks. Well, no internet message, including voice over IP, is restricted to a single path. Packets fly all over the place and then get reassembled at the destination. Part of the reason for the strength of the internet, for the capacity of the internet, and one of the reasons why the internet is not nearly so much a natural monopoly needing regulation as the public switch telephone network was. So just from a technical point of view, and I don't want to overemphasize it because any technologist understands this, the internet just doesn't look like the phone network. More important, should it be regulated like the phone network under Title II of the Communications Act of, I think it was 1935 or sometime a long time ago. Yeah. 34, thanks. I knew you'd know. And my answer is definitely not. Look at what we got from Title II regulation. We got a phone network which at its inception was a miracle of modern design, that in the ensuing 50 years had about 2 innovations, dial tone and 800 numbers. And regulation was one of the things, monopoly was another, that almost guaranteed that the public switch telephone network would be innovation free. And that worked. It was innovation free. And even if we look at a legacy today, if you happen to have an old-fashioned phone on your desk, can it send a text message? No. Can it do any of the things a smart cell phone can do? No. That's partly a result of both monopolies and of regulation. If we look at a smartphone and all the wonderful things it can do and all the things that keep being innovated there, that's an example of unregulated technology being able to grow more quickly. You would think that a desk phone where you don't have to worry about weight, where you don't have to worry about power, would be able to do much more than a phone that has to be small enough to clip on your belt, that has to worry about battery power. Not the case. So if we want the internet to be innovation free, then we can regulate it under Title II as we did the phone network. or we can do what we've done for most of the internet's life up until 2015, which is have a very, very light regulatory touch. This argument, and I'm giving you a long-winded answer, but this argument is very strange because back at the end of the 90s, because my company depended on the internet being unregulated, the telephone companies, some of the same companies who are now ISPs, were eager that the internet be regulated so that innovation on the internet wouldn't interfere with their business models.
Mm-hmm.
And so I spent a lot of time lobbying the FCC, and at the time, internet players like Google and Amazon were very much on the same side I was, saying that regulation would kill innovation on the internet. And that's what the proponents of regulation wanted to happen. Well, first, the Clinton's FCC under Reed Hunt decided not to regulate the internet. That got formalized later in the George W. Bush administration with so-called Pulver decision, specifically not to regulate the internet. Internet startups.
And Pulver was another voice entrepreneur.
He was another voice entrepreneur, and he did a great job on that.
Yeah.
That's right.
Yeah.
And before that, Free World Dial-Up. And so within 2 years, the cost of phone calls to China went from $2 a minute to 2 cents a minute, because we could use innovation on the internet to break the monopoly on the regulated telephone network. Notice the regulation protected the high cost. The regulation didn't prevent the high costs and high prices. Now, fast forward to 2015, and companies like Google and Amazon, who are relatively much more powerful than the ISPs, are in favor of regulation. I think maybe because they're the ones who now think they can capture the regulators the same way that you could argue the telcos did earlier. And because now they're the incumbents, and I think they're the ones who are afraid of disruptive innovation. This is all done in an Orwellian sense in the name of net neutrality and a free internet. And I'm all for a neutral internet with a small n.
Yeah.
But to have that accomplished under Title II regulation means, I'm afraid, that we end up with both an innovation-free internet and, incidentally, a great danger of government intervention in content. It amazes me that some of the people who are most opposed to the current administration are in favor of having presidential appointees under Title II to be the ultimate deciders of what could be done on the internet. I'll stop and give somebody else a chance.
So what do you think, Barry? Is Tom right?
Well, I read the letter, the EFF letter. The first thing that impressed me was that everything that he said in there could have been said in a lot less than 50 pages. 45
Yeah.
pages. Okay. It's unfortunate because it struck me as written by somebody who desperately wanted to believe that somebody at the FCC doesn't fully understand the internet, which I think is a terrible approach. Browbeat and lecture and give definitions for 40 pages. You don't understand this, you don't understand this. I found a sentence that I would disagree with. Make your point.
I thought it was kind of bizarre that when they went to define packet switching, the reference they used was a law school textbook. And
I saw that. Yeah.
It strikes me that when you ask engineers to define something like that's that fundamental to the internet, they're not going to refer. I mean, it was a good law school textbook, but
right. And who knows? Maybe it was correct. But I'm just saying. I just was dragging through that and saying, why? Who are you browbeating? And who's your target audience here? Who are you trying to explain the internet to? Why are you doing this? This is the kind of thing that some engineers will do. Challenged on a policy issue, they'll assume you must not. If you disagree with them, you must not understand the issue, and we'll start explaining the issue to you. And that's a terrible approach in a policy environment to meet the other side on the defense.
Well, actually, that part of it, the what they call the brief summary of the internet or brief introduction to the internet, whatever it is, sort of Internet for Dummies part of the letter.
Yeah.
It was recycled from an amicus brief that EFF filed in the U.S. Telecom challenge to Tom Wheeler's open internet order. So they added the section at the end about DNS, but the rest of it was pretty much, some material that they had developed in a different context. But they did add the stuff about how Chairman Pai doesn't understand the internet.
Right.
Yeah.
Well, it invites criticism of their policy position based on going through and seeing whether they're correct in every detail in their explanation. Do they understand the internet? They set that up as the contest. Which side understands the internet? Which left me kind of empty. Talk about the policy. Talk about. I understand the idea of permissionless innovation and all these, and that's all good stuff, right? And that's
right.
Policymakers may respond to, right? They can understand permissionless innovation. Or they can understand, how. I think they got better when they were talking about like bandwidth shaping, and how this might impact or intrusion, interference. I guess they use the word a lot. Where packets are intercepted and changed, for a vendor's pecuniary gain, right?
Which is something that pretty much hasn't happened on the internet. I mean, there have been some mentions of it, but as far as the paid fast lanes and all that, the closest we got to that is like zero rating, where people that are mobile customers could access certain services like Facebook without that counting against their minutes. But
well, zero rating, as I understood it, was originally introduced in Africa, third world, poor, underdeveloped nations. Because these people can't afford a nickel of time. And it's all charged. There's no such thing. There's no such thing as bundled. For many of them, they get a basic cell phone. I don't know what they get with it, but it's very.
Yeah, I mean, it's mostly it's something that seems to have great appeal in countries where the only communication device that's sort of widely deployed is a feature phone, and they're trying to kind of move people up from the feature phone to the smartphone, and cost is an issue, and it's I think it's like the old strategy, the first one's free. That you gotta give people some incentive, like what's the internet good for? And if you don't live in a first world country and use it every day, it's kind of hard to remember what is it good for?
Well, and that's the concern with zero rating, even in undeveloped countries, is that it gives an unfair advantage to deep pockets. Because they can give away time frame. Of course, you have no money. You're gonna go whichever vendor is giving you the most free minutes, or not charging.
Yeah, and so on the regulation point, I mean, as the earliest ISP, you weren't regulated under Title II. I mean, you were actually you founded the world before the '96 Telecom Act passed, so. There really wasn't such a thing as Title I and Title II, but the FCC had done their computer inquiries, and they created the distinction between a basic service and an enhanced service, and your ISP was considered an enhanced and therefore deregulated service, right?
Right. I mean, it was several years. Obviously, it was 1989, and we were completely off the radar as far as any of that went. The only thing that even resembled regulation was the first reaction from the National Science Foundation, the NSFNet people, was 2/3 of it blocked me, and the entire net blocked me. That's all. They just blocked me in their routers because they said, this guy's letting the public on. He can't do that. Imagine that. I'm being blocked for allowing the public on the internet. In fact, 2 years later, that resulted in a letter from Steve Wolf and the committee, a committee that was meeting, giving me permission to put the public on the internet. I actually have a letter giving me permission to put the general public on the internet.
Oh, so permissionless innovation wasn't a thing in 1989, huh?
Well, permission to get to their people. I get to whoever was willing to, which was a third of the internet, and it grew. People got used to the idea. Of course, other ISPs found it pretty quickly. And, they were all in favor. So, slowly but surely that fell away.
Yeah.
These were just mostly.
Well, there was a bit of a backlash when AOL allowed all of their customers on the internet because they flooded into Usenet, and the IQ level of the average Usenet group, dropped substantially. But,
Yeah, we used to talk about the term the eternal September,
uh-huh.
which was a term from Usenet, which was all the students returning in September, and they all get Usenet access.
Mm-hmm.
And so you suddenly got a couple of million new users on this discussion and chat space.
And they're like, is this
And they
thing
don't know
on?
the rules. They don't know the etiquette. So now AOL gave us
Mm-hmm.
the eternal September.
Yeah.
It's no longer just in September, and how are we going to explain anything to these people? It worked out. I mean, I wasn't that concerned, but it was a funny observation.
Yeah.
Yeah.
Yeah. So, John, you were chuckling when Barry was talking about the acceptable use policy and the NSF net, and you were on ARPANET. You were like the 12th node on ARPANET. So,
Right.
from the beginning, that was so on Flag Day. You were there. You were already. Oh yeah, you were on well before Flag Day. Yeah.
Oh yeah, Flag Day was until '83.
Yeah, that was another 12 nodes, but it was a different 12 nodes.
Yeah, no, this is 1970.
Yeah.
Yeah. Well, I'd have to agree with Tom, because if you really go back and look at how packet switching came about, Paul Baran's whole idea was this was the not voice network.
Yeah.
In fact, it was designed not to do what voice did. So that's one thing. And then, of course, the next progress of that was with Pouzan coming up with the datagram. And actually, I think it was fairly common in those first few years. The four characteristics that I've always said characterized the paradigm shift that we saw networking taking, which the internet builds on, is that we had layers of different scope, distributed shared state of different scopes. It was a peer network. There was a movement toward non-deterministic versus deterministic technique, and not just in networking with the datagrams, but this is the same time when operating systems became interrupt driven as opposed to polled.
Mm-hmm.
And Ethernet was another good example of that.
Well, and the RAID concept in storage, right? That's
right.
Yeah.
And then of course the other one was that we all saw this not as distributed computing, not telecom.
Right.
And in fact, it's been really interesting because we've said that networking is inter-process communication, and lately we've gotten a reaction that's a radical concept, when in the early 70s nearly everyone thought that networking was just operating system inter-process communication.
Yeah, I think Bob Metcalf was one of the people that made that point right early on. That
he and actually Dave Walden has a RFC of even smaller number.
I've seen that.
That calls it IPC, and so yeah, it was a common idea. So and the EFF.
So this let me interrupt. Just so the notion that protocol layers have to do with, like, there's some sort of a functional difference at each layer in the protocol stack. That strikes me. I mean, that EFF makes that argument that, that there's a layer 2, which they don't talk about. Layer 1 and layer 2, they don't talk about at all. It's like, I think that would basically destroy the argument. So they're talking about layer 3, which is IP. And they might make some mention, and they mention application layer, and there's some passing stuff about TCP, but they make this argument that these layers each do something functionally different, which is sort of a lawyer's view of layers, right? That's not the way you see them, is it?
Well, that was a very early idea, and that idea came from Dijkstra's paper on the THE operating system.
Mm-hmm.
And actually, when I went back and started looking at it, and by the late 80s or so, we'd been working this problem for some time, And we always had problem that there were always functions that repeated.
Right.
And so that was breaking. And at one point, I just realized that no. The layers all do the same functions, but they do them for a different range of the problem and over a different scope.
Different scope.
And actually, the Cyclad guys by 1972 had figured out that the primary property of a layer is scope.
Right.
And
Cyclad, by the way, is the French network that is the immediate precursor to TCP/IP's organization of functions with an unreliable datagram layer and an end-to-end transport layer that does error correction and flow
control. Actually, I think part of the thing that the internet people missed was in Cyclad, the link layer was an HDLC-like protocol because lines at the time were really unreliable. And so it did point-to-point error control, so it was really reliable point-to-point. The network layer did relaying and would lose packets due to congestion. And then you had the transport layer. This was, Louis' big innovation, that he realized that, the users were never going to trust the network anyway. So, you didn't have to be perfect. You only had to make a best effort. Have an end-to-end transport protocol that recovered from errors.
Well, I mean, you still have to do error checking in the computer because, memory failures, and there are things that can happen in the computer.
But the point is, the layers only have a certain scope. And really, to talk about stacks is a misconception. Because not all systems have all the layers.
Yeah, it's kind of more like an onion, right?
It's like an onion with multiple centers.
Okay. That's kind of hard to visualize.
Can I interject something?
Sure.
That if you're going to use, this is one of my issues with net neutrality, which is let's hold on to that layer model.
Yeah. And
one of my problems is that net neutrality can go on at every layer. Net neutrality issues go on at every layer, and they simplify it. Mostly layer 3, right? The IP layer. And I think they're missing how many ways determined people with money could interfere with transmission and applications, and that's the fatal flaw on telephony, on the telephony model, because they're looking at a connection model, they're looking at a bandwidth model. Go ahead.
Well, but see, then they would have to admit that there's processing going on.
They have to admit, I'm sorry?
They'd have to admit that there was computing going on. I mean, if you'll notice in that letter, they talk about BGP being an application protocol and doing routing, but they don't talk about intra-domain routing that uses the link layer to transport stuff around. In fact, routing is not an application protocol; it's layer management.
Right.
And so they leave it out because it doesn't fit their model. I mean, even DNS is not an application.
Yeah, I mean the protocol that actually does the routing is IP. BGP provides the information to routers to use to figure out where the.
I think that's another misconception that we have. We talk about IP being stateless, and that it's resilient to failures, which Tom was pointing out, and that's all true. But the reason it's true is because in that model, everybody knows how to route everything. In the phone company model, only the edges know how to route everything.
Well, the only thing that gets routed on the telephone network is the call creation. I mean,
but the thing is that there's a much wider distribution of state information.
Right.
In the packet switch network.
Yeah, I mean, essentially, the routing table defines the state of the network at a certain point in time.
That's right.
And you get the resilience from the internet because every time a router forwards a packet, it goes and checks the routing table to make sure the state is the same as it was the last time.
Yeah.
And so, it can pick up on changes in the path architecture from point A to point B, you know, on a fairly speedy basis.
But getting back to net neutrality, I was like, that's a great example, illustrative example. BGP, right? How much mischief can be done at the BGP level? And it brings up the real, I think the real issue here, the real problem here, independent of the FCC's approach of this, you know, regulation, like they can regulate this, which is that we have the same companies providing core tier 1 BGP as they're providing the applications.
I agree.
Creating the interest in this mischief, right? Having the monetary interest in all this, right? So they can cause as much damage with BGP as they can with bandwidth or peering, you know, fooling around with peering. I mean, it's a wonderful tool for that. And I'm saying all the way up the stack, you can find this kind of problem. You just got to stop for a minute and think, you know, how could I cause DNS? I could slow down DNS requests. You know, I could do all sorts of mischief, you know, for my competitors. You know, it's not really bandwidth per se. It's priorities perhaps on the DNS servers they rely on. And so,
well, I mean, one of the first events that actually brought net neutrality to the public's attention was that Comcast BitTorrent thing. And as that issue has been explained to me, what was actually happening was that Comcast had just introduced their voice service. And right after they introduced their voice service, and they're now the biggest voice provider in the country, a lot of people who were Vonage users were complaining that their Vonage wasn't working as well as it used to be, and they suspected, as one would, that Comcast is deliberately degrading their VoIP so that they'd have to buy voice service from Comcast. And the Comcast, which is, you know, that's like not the best thing for public relations, and certainly if it was happening, they'd want to deal with it. But the engineers looked into it and they found out, well, actually the problem is the people who are complaining are in neighborhoods where there's a lot of peer-to-peer going on. And so before peer-to-peer, there really weren't applications that stressed the uplink. You know, because web browsing is like 100 times more downlink traffic than uplink traffic. You just click on the link and you do the get, and, you know, it's like 1 or 2 packets, and, you know, and now you're downloading, it's now an average of 3 megabytes per web page. And you know, but BitTorrent, you know, was able to saturate the uplink in a way that had never happened before. So they had to figure out how to throttle that, and they didn't have a good tool to do it. So I mean, but this is the thing: the telephone network is designed in such a way that callers don't have an impact on each other, right? I mean, I'm calling, my neighbor's calling. You know, we have a defined segment of network resources that we can work with at any given time, and we don't really have side effects on each other, except, you know, in the one case where everybody wants to make a long distance call on Mother's Day, that you may not get your call connected. But once your call is connected, there's no side effects between users. But the internet is all about breaking down those barriers between the calls so that the whole capacity of a link is available to like whoever wants it at any given, you know, sub-second interval, right?
Yeah, a very good example of that difference was on 9/11, when the switches that were Verizon switches underneath the World Trade Center, which were of course destroyed, and so the public switch telephone network pretty much went out of business in the New York area. What remaining, it had some capacity to route around, but what capacity there was totally saturated, which meant you couldn't make a call at all. You couldn't get a dial tone, which is the way resources are allocated. We were a wholesale voice over IP provider. We never did domestic calls because we weren't competitive, but everybody's switches were attached to us. And all of a sudden, we at ITXC were carrying that domestic traffic that couldn't be routed through the Verizon switches. We were providing lousy quality because the internet was congested, on the internet, it bends, it doesn't break. And the PSTN doesn't bend, but it breaks.
Right.
So, I wouldn't boast about the quality of the calls that we got through, but the internet as a whole, not just voice over IP, but email and other forms of messaging on the internet, let a lot of people know that a lot of other people were okay, where the PSTN, because of its inflexibility, and interestingly, because of its insistence on you get absolute quality or you get no quality at all,
right,
just suddenly broke under the load.
And a lot of those are just 1-bit messages, right? Like, I'm okay, or no answer.
A few more than 1 bit, but not 140 characters anyway.
Yeah. Well, John, you've said that it's your kind of impression that the internet is actually too much like the telephone network, and because of right. I mean, it's a subtle point. You want to explain that?
I'm not sure what you're referring to, but
the way the internet does routing is not as dynamic as it could be.
No. I mean, well, actually, no. It connectionless route. The whole connectionless thing is a lot more resilient, and as Tom was just saying, it bends but doesn't break, as opposed to the phone system, which doesn't bend but breaks. No, I think the point I was making is that they were pointing at BGP to push the argument that they wanted to make, when if you looked at where all the routing occurs in the internet, that argument wouldn't hold.
Right.
Because, routing has always been considered layer management, part of the layer.
Well, in routing, apparently that word doesn't really mean the same thing in the PSTN context, in the telephony context, that it means in the internet context. Because the thing that the telephone network routes is calls.
Yeah.
So when I dial your number, my request to connect to your telephone gets routed over some path that is chosen by the telephone network to be the best path for that call request. But once we're connected,
it doesn't change.
It doesn't change. I mean, it's like everything, it goes, like Tom was saying about the pads, it goes over the same pads.
Well,
so,
it is funny that more, and I think Tom hit up on another good aspect of this, which is, I think the incumbents right now believe that the internet, they don't want the internet to change. So they really do want to stifle innovation in the internet. They want all the innovation to be in the applications.
Right.
The trouble is, we're building on sand right now. I mean, when I started digging around to figure out what the fundamentals were, I was really fairly shocked to find out, well, some of the stuff we already knew about. We knew that we were missing 2/3 of the addressing structure that's required. And we've known that since the 70s. Okay. I was really shocked when I went to write a paper about the economic politics of what was going on in the 70s between the phone companies and the computer companies. And the old thing of you forget after 30, 40 years. And I realized that in the mid-1970s, the network idea that everyone was pushing toward was a transport layer with transport layer addresses over a network layer with network addresses of less scope, specifically mobile networks, and then a data link layer with data link addresses over even less scope. So you had 3 layers, all of different scopes, all with their own addresses. We don't have that today.
Right. I mean, we have
lost the
one
internet
address that basically the IP address, which is globally unique, doesn't have any structure to it particularly. It's kind of a reflection of the MAC address, which even has, MAC addresses have more bit, they have 48 bits, and IPv4 addresses only have 31 usable. And it stands for the same thing, right? It identifies an interface. It doesn't identify a computer.
That's the second problem. It identifies the interface, not the node.
Well, the Xerox network systems, they got that right. I mean, they addressed the network and the host independently. And if you were a host, you could have more than one connection.
Yeah.
You could have an Ethernet. You could have a couple of Ethernet addresses and something else. What?
Everybody got that right except the internet.
Yeah, I mean Xerox, DECnet, and Cyclade. I mean, were they being too clever? This was back in the day when you had to twiddle bits to figure out you could take an IP address, and then based on what the first two bits were, it told you how many bits in it identified the network and how many identified the node.
No, I really.
And so they sort of had a network address embedded in there, but then that kind of went away with CIDR, right?
Well, no. What happened was, I mean, really, the ARPANET, in the ARPANET, your host address was your IMP port number,
right?
Interface, and the internet just did the same thing, and they never changed it. I mean, we realized there was a mistake in '72
with the Tinker Air Force Base and
the old Tinker Air Force Base story. Yeah,
the Air Force Base wanted redundancy because, I mean, they kind of bought into the idea that this packet switch network would be resilient to attacks, right?
Yeah, right.
And so they figured, well, if we're going to do that, we're going to need more than one connection.
Right.
So we'll have to have something to fall back to. Well, it turns out if your connection is identified by the same thing that your computer is identified by, you can only have one connection. Well, so we've sort of taken this wonderful resilient technology and sort of dumbed it down into something that is less than what it could be, right?
First of all, as I always say, the ARPANET, nobody had ever built one of these things.
Well, yeah.
And, and we had a lot of problems to solve, like just how to move data, because none of the computers we were connecting had ever been built to talk to another computer.
Well, and that's what computer engineering is
really
like.
On the top-notch thing, but once and really to some extent, and I think this is why you often see in software that the first was a throwaway. We're so removed from the physics and what the principles will turn out to be that you really sort of have to build one in order to see what you should have done.
Yeah.
And then
well, it's like we used to say when I did software engineering
in fact, the BBN guys spent a lot of time with the Cyclade guys, working with them so that they wouldn't make the same mistakes they did.
Well, this is a bit of the history, I think, that isn't really well understood, is that the path from ARPANET to the internet it's not a single hop path.
No.
I mean, because what happened is the guys at BBNN in Boston who created ARPANET, after it had been in operation for a few years, they kind of had a good grasp on what the limitations were. And Louis Pouzin and his research group in France, they were ARPANET users, and Louis decided he wanted to build a network that addressed those shortcomings.
God was never on the net. On the ARPANET. No, what the difference was...
Louis was.
No. Cyclade was never connected to the ARPANET.
No, not Cyclade, but Louis himself personally was an ARPANET user.
Right. But no, the thing was, the ARPANET was built to be a production network.
Right.
To lower the cost of doing research amongst ARPA contractors on other things.
Yeah.
Okay, so BBM was limited in how much they could change. Pouzin built Cyclade to be a network to do research on networks. So he had free reign to try.
And people are always complaining about the network is down because somebody's running an experiment, and I need to send this email, and they're like, sorry, dude, it's a research network. This is
and so the Cyclade network was never used in France the way the ARPANET was used in the U.S.
Right.
Because they were really more interested in exploring, and understanding stuff. And in fact, that's how the datagram comes about, because Louis said, what's the minimal thing we have to assume
Mm-hmm.
and then let's see what we have to add, right? And
Yeah.
and that's what's led to the whole datagram and end-to-end transport protocol. So
That's very Cartesian,
yeah, very Cartesian.
very French. Yeah.
Yeah, and you know, so but that's how they got to that. And I think, the internet, once they were used to that idea, in fact, just the whole idea that you're naming the host is still very much in their minds.
Yeah, yeah, Louis, the stuff
address
that
is
they
not-
wrote about Cyclad, it's really fascinating to read that, because one of the things that he talks about is the desire to set up a routing system that would enable a host to break a message up into parts that could be sent in parallel over multiple paths through the network at the same time.
Right.
Which is kind of the idea behind IP fragmentation and reassembly, and the kind of resequencing that TCP does. But it doesn't actually happen that much on the internet, because we do tend to sort of stick to a path until it changes.
Well, there's that, and then there's the fact that.
But I mean, can you even imagine a telephone call being split up and sent, and have parts of a telephone call being sent in parallel on multiple paths at the same time? It's just not conceivable.
Well, that was the challenge of voice on the internet.
Yeah, but remember, this was a network built to not be a voice network.
Yeah.
Yeah, those of us who were early in voice over IP lived with that, of course, all the time. That
right.
The network was built not to do voice, almost as if it had a hostility to voice.
Exactly.
Right.
Well, the internet was first built on top of the phone network. I mean, quite raw. We had dial-up.
Yeah, right.
And then the phone network was reinvented on top of the internet.
Right. Very ironic.
And now they're going through a cycle. But can I make a comment more on the policy?
Sure.
I mean, my problem here is, it's funny how they're using the Communications Act of 1934, right? Which trafficking in language is being resisted. I was reading, and it says, well, it regulated the various telecoms. I read one phrase, right? Mm-hmm. And said, no, it created one monopoly.
Yeah.
Okay, there were not
the various one telecom. Yeah.
Because it granted that monopoly, that's what gave it the authority. We created a monopoly of the entire phone system, with a few tiny exceptions. Right? And it was by that power, right, to ignore antitrust monopoly regulations, that the FCC got that, and the limited bandwidth, the limited spectrum arguments with radio. This is what gave them emphasis. We're going back to anyhow. One of the things at AT&T, one of the agreements of the monopoly was they couldn't go into applications.
Right.
When they came out with Unix, the Unix operating system, I remember I first got it in the 70s, and they would tell us over and over again, we're charging you $60 for a tape copying fee. Okay, we are not allowed to sell. We are forbidden, right? It would cost $60 for the mailer and the tape, the round tape. And they were forbidden. Well, I think somewhere therein lies a big part of the solution to the net neutrality question. Okay, I think what's needed is for the FTC and others to step in and split the wire plants, so to speak, from the application plants. Comcast wants to run a video or cable TV network. Fine, good luck to them, but they can't also run tier 1 networking, okay? Because that creates a conflict of interest, especially the way we have small.
You also have to allow for innovation in the network.
I'm sorry?
I said you also have to allow for innovation in the network.
By whom?
By people who want to innovate with the net. The network itself is the problem. There are fundamental flaws in what we've got.
There are, and there's the IPv6 routing issues as we increase addresses, et cetera. I'm sorry? 2/3
of the addressing is missing. Congestion is probably the The congestion management stuff is the worst you could ever have.
Yeah.
I mean, this thing is not built to last.
Yeah, so the idea, I mean, I think a lot of what
out already that the ROI on the internet has gone negative.
A lot of the, I think the sort of emotional drive for net neutrality is the idea that the internet is damn near perfect. They're like, you know, we want to, when you listen, certainly when the politicians talk about it, the arguments they make are they want to keep the internet the way it's always been. They want to preserve, you know, the norms that have allowed the internet to flourish and all this. But, you know, and the assumption is it's really kind of, I think, telephone thinking that the network just is what it is. And the only interesting stuff is what happens, you know, in applications. But
well, that may be true, but the thing is, the internet made some really fundamental errors.
And I mean, and that's the point, that keeping the internet the way it is forecloses an awful lot of opportunities for new applications that are not really practical to implement over today's internet because of, you know, the quality of experience issues, the congestion issues, the financial issues.
Well, just what you could do. I mean, the way things are set up, you are almost required to never get beyond a client-server model.
Yeah. So you're going to say something, Barry?
I was just going to say that I think the assumption of politicians, like the phones, like the cable TV, any of these systems, is that if it breaks, you know, some bunch of propeller heads will go fix it, not our problem. And so they deal with it on the level of policy. You know, this is what they understand. They tend to be lawyers, policymakers. You know, they understand Game of Thrones. You're moving the little pieces on the chessboard of who owns what, who has what power, who has what authority. You know, they're not going to consider these issues of technological problems. I'm sure they screamed within the phone company. Yeah. I mean, they used to actually, you know, they flipped relays. I mean, used to be able to get lines that were permanently flipped, right? That you could actually put an ammeter on and measure it, put a current through on both ends. Okay? They were physically connected between here and, say, Cambridge, called, you know, but anyhow, you could buy these for $10 a month. Something, alarm tips, I don't know what they would call, something like that. Anyhow, you know, so the underlying technology is just not their interest. Okay.
So where do you come down on the policy side, Barry? One of the options is that we accept the fact that neither Title I nor Title II really is an appropriate model for internet service, and ask for Congress to give the FCC a targeted authority to prevent internet service providers from misbehaving, from, as the LA Times so eloquently put it yesterday, monkeying with packets.
Well, I said, I think what we ultimately will need to do is a long haul, is split the wire plant, the IP packet delivery service, you know, all that layer, you know, from the application deliveries. Okay, just like they did with the AT&T phone system, you know, that you either run the wire plant or you're an application.
Yeah, but that was a monopoly scenario, right? I mean, they could split that and say, you know, AT&T can't sell Unix because it's got a telephone monopoly, but nobody has a monopoly over internet service.
No, there's 4 of them, 5 of them.
Yeah, I mean, well, that's not called a monopoly.
That's not a monopoly. There's almost 5 of them.
Richard, I disagree with Barry, even though the argument is tempting, for a couple of reasons. One is that the wire plant isn't the only way that we deliver internet packets anymore. And so you want innovation at all levels, whether it's microgrids, low Earth orbit satellites, balloons.
I don't mean literally wired.
But then, so if you're saying now the non-literally wired is also a monopoly, then you prevent innovation by little guys in that space. The other problem is the one that you and John were getting back to, is that, there's a hypocrisy in this, not that you're being hypocritical, but a lot of the wired network belongs to Google and Amazon, but is carefully not in what the FCC regulates according to Title II. So those people, those companies have their own backbone. They have their, it's like and they have data caches. It's like the local warehouses on Amazon, but it's the cyber equivalent. So if you're saying, okay, we're going to regulate the backbone if it belongs to Comcast or AT&T or Verizon, but what are we going to do about the private networks, which certainly advantage the packets of Google and Amazon? Are those free to remain competitive? I think they should be, but then it's hard to regulate the other ones.
I don't think that's a problem. I mean, we've always had that. People used to run voice telephony over barbed wire.
Right.
But more specifically, Sprint. What does Sprint stand for? Southern Pacific Railroad Internal Network, internal telephone. That's what Sprint is an acronym for. The railroads ran their own telephone network. That's never been a problem because the public's not involved. The public's not affected.
The public is affected by it, though. If you're hosted on Amazon, you get to ride on the Amazon network. The reach of the the networks you were talking about, like Sprint or like the barbed wire phone networks, which I love, those are splinters. But if you look at Google's worldwide network or Amazon's worldwide network, those are hardly splinters. If you look at who's Cisco's biggest customers, it's not the traditional telcos, it's not Comcast, it's the very internet companies that want to have some of the other internet backbone regulated. And so I'd argue they already are competitive backbone providers, therefore there's competition, and the regulation, far from accomplishing the aim of neutrality, is actually just putting its finger on the scales.
Well, so what this starting to look like is an incumbency protection racket.
But that's what I think. And it's nobody sits down and says, now I'm an evil incumbent, I can do evil. It's just that just as we get older, we tend to get more conservative. You get more dominant, you tend to be more protective and less open to innovation, and thinking a little bit of control would be a good thing, and I think that's where we are.
If you've got a worldwide network like Facebook and Google do and Amazon, you're in control of the quality of at which you deliver your product to your customers, because you can decide where to connect to the ISP networks, how much work to do. And if you have that ever increasing power in your private network, and you also are regulating the hell out of the ISP network so that the progress in their quality is retarded, slowed down.
Well, also,
then you've got an advantage over incumbents that might challenge your business model, right?
Right. If I want my business to take advantage of Amazon's network, I can host on Amazon. And by the way, I think Amazon hosting is wonderful. I use it, but really well. I can host on Amazon. But suppose that I didn't want to host on Amazon, but I wanted to buy better connectivity to various points. Title II regulation says that the carriers who could sell me that by the drink aren't allowed to. So they're not allowed.
You can buy it from Akamai or Limelight, but you can't buy it from the people who could actually provide it at the least cost.
That's right.
Yeah. And that's to me, this is the essence of the Fastlane controversy. That it is very definitely the case that the large ISPs would like to be in the content delivery network business. They're really well positioned to do it. They already have the infrastructure in place. They've got the agreements, excuse me, with the other ISPs, and they could offer that service at pretty substantially lower price than the current CDNs do. Right. But they're barred by law from doing that. But that actually sort of prevents them from the kind of abuses that you might expect in a vertically integrated monopoly. But it also deprives the public of lower cost to get to those services and effectively more startups. And and the main thing is that what the ISPs could do, if they were allowed to be in the business of selling customized transmission services for a fee, we could get the sort of the voice equivalent of a CDN.
Also the whole innovation thing has become, not in the network, and it's just become a morass of patches.
You can argue that, you know, I'm as unlicensed engineer, but in general, I like a layered architecture where one layer doesn't know anything about the other layers. It's a much cleaner environment to develop in, except when you need radical innovation. And my favorite example of that is Apple's development of the Macintosh, that you couldn't have taken that step forward without owning every layer, without owning the hardware layer, the software layer, without developing the first applications. It's not a good model, except when you have to make a change at every level to get to the next place.
Well, actually, what we found was by doing precisely what you just said, making sure the layers were completely independent, actually led to a much simpler implementation that required, I mean, first of all, we brought up the fact that the multi-homing problem earlier about, turns out if you do that right, it not only reduces router table size by at least a factor of 4 to 5, but enables mobility with no new protocols at all.
Yeah.
I agree with you.
The implementations are anywhere from 5,000 to 1,000 times simpler.
Yeah, no, I absolutely agree that, architecturally the layers ought to stay simple, and I didn't say that well. I think there's a time when, in order for innovation to happen, the same organization has to be able to innovate in all the layers at the same time. Yeah. That doesn't mean to break the layering, but it's say, okay, this breakthrough is possible, and we got to think about that in every layer, not still keeping the layered approach.
Yeah, I mean, but the engineering problem in setting up a good layered architecture is that you don't just build firewalls between the layers, you define communication that takes place between the layers.
Yeah, absolutely.
And I think you can have a highly functional and very efficient layered model if you can do the right kinds of communication across layers, which, if you look at IEEE 802 standards, that's the first thing they do is they define all the messages and all the signals that cross a layer boundary such that you can actually, develop them independently and get a highly functional system. And I think when a company like Apple takes it all in-house, they're doing everything from the applications through the operating system, through the hardware, they're ensuring that the different elements of the system communicate with each other very well. I mean, all the information is available. One of the things
that Apple did, which I think has never been really well recognized, is that they had very strong APIs.
Yeah.
Yeah, from a developer's point of view, that was the whole secret. And you could get at the power of the layers below you without knowing a damn thing about them. And so you could do wonderful things.
And the way you did that on the IBM PC was that you read the source code to the BIOS.
Exactly. You made your own interrupts, and
you either manipulated the hardware directly, or you went right into a real low level routine.
Of course, if somebody has a design for a new network, an entirely new network, it's completely straightforward to simulate it on the current internet. I mean,
well, John is that person. John has RENA is the new internet, recursive internet architecture. That he lays out in the book.
And we've been doing that.
Sorry?
And we've been doing that.
Yeah. They are simulating it on the existing internet. How about that?
Innovation,
okay. Well, we should probably, I think we're going to start losing our audience here where we've been on for a little over an hour. So does anybody have any pithy remarks to close with that you want to make sure that the world understands?
Thank you.
The world.
Yeah. The world. 1989 was a great year, Barry. That's the last time the Oakland A's won the World Series.
Well, there you go.
Yeah. There was that little earthquake thing though, but yeah. Okay. Well, thanks an awful lot. It's been a great discussion. I'd like to get you all together again sometime and do some more of this. It's like the only thing missing is some beer. Okay.
All right.
And I'll write this up for the High Tech Forum podcast. And I forgot to mention Tom's op-ed in Morning Consult about who has fast lanes and who doesn't. I'll put a link to that in the blog post for people.
But
that
if you
didn't
put a
catch the
link
slide.
into my blog, not only it'll help promote it, but there's a lot more
I will.
content in there.
I will, in fact. Okay.
Okay, great.
And yeah, great. So great to see you guys, and come check us out at hightechforum.org.
Okay.
And if you haven't already made your voice heard to the FCC, go ahead and do that too. You can join the 20 million robot comments.
Send your bots.
Yeah. Okay, folks. Bye.
Bye-bye.